My name is Agraj Khare. I am a PhD student here at the University of Maryland Center for Environmental Sciences Chesapeake Biological Laboratory. My advisors are Dr. Hallie Kilbone and Dr. Johann Schiff, and my work primarily focuses on reconstructing past sea surface temperatures using coral skeleton chemistry. I travel to the Florida Keys and the British Virgin Islands. I collect seawater samples and coral samples. The importance of this research, the importance of reconstructing past climate lies in the fact that today obviously we see a lot of climate change. To say that a particular process is governed by the climate change and not by the natural variability in the Earth's climate is something that you cannot properly tell with the length of the climate information that you have. We need to know the background state of Earth's climate such that if we see some changes in certain processes like storm events and storm frequencies in the present, we could say with confidence whether or not this change in the frequency of storms is due to climate changing or is it just natural variability of the Earth's climate. We are collecting continuous seawater samples in both Florida Keys and the British Virgin Islands, and we have placed corals there that will grow simultaneously as we collect the seawater, and therefore we'll have samples from both seawater and the coral, and we have placed temperature loggers, so we'll have temperature information. So overall, we'll try to see how much of the influence the seawater chemistry and the temperature have on the coral chemistry. So the corals can be considered to be analogous to tree rings. Every tree ring records a certain information of the climate, and in a similar way, coral skeletons also record the climate as they grow along their growth axis. As the coral is growing, it is recording the environment signatures like the seawater chemistry and the temperature. And as you measure the coral's chemistry going along its growth axis, you can basically measure the environment information from it. And so we can reconstruct past temperatures using this growth axis. The overall goal of my study would be to find certain reef environments that are probably more prone to seawater's chemistry fluctuations, such that the temperature information is not properly recorded in the coral. And so what ideally people who reconstruct climate would like is that the coral is only recording temperature and not fluctuations in seawater chemistry. So I'll be able to say like this particular reef setting is probably not as well suited to do some climate reconstruction, and a different setting may be better.